Hello there, Nareg is here. Today I'm going to talk about, again, small part related to vectors. We're going to discuss how vectors could be useful in order to demonstrate some geometric relations. The first thing, which is the easiest use of the vectors, it's whenever you have two equal vectors and they give you a parallelogram. So let's start with that one. Whenever you have a certain vector AB equal to CD, you can say that ABCD, actually ABDC, is a parallelogram. Or in case you had ABDC parallelogram, you can conversely say that AB is equal to CD. So how do we represent? Very simple. This is our vector AB, and this is the vector CD. Both of them are equal. So since AB is equal to CD, you will have your AB DC a parallelogram. All right. So this is the first one. Now, the second one, whenever we have two vectors, a relation between vectors, let's say I had AB is equal to K times CD. K is a certain constant which could be from the real numbers. So whenever I have AB is equal to K times CD, that means that the line AB is parallel to the line CD. Or conversely, whenever you have AB parallel to CD, it means that there is a certain relation that can be written as AB is equal to K times CD. So in this case, K is, just like we said, it's a real number. So this is AB. Let's say AB is equal to 2 times CD. So this is CD. So as you can see, AB is a double of CD. They have the same direction, same orientation in this way, in this case. Since they have the same direction, that means that they are parallel. So the line AB will be parallel to the line CD. All right. So this was the second use for related to the vectors. Now, what happens if we have a similar relation, just like this one, AB is equal to K times CD, but instead of CD, there is the point A or the point B gets repeated. So we have a common point. So what happens when we have a common point? Let's say AB is equal to K times AC. Now in this case, you can say that the 3 points A, B, and C are collinear. Or if you had A, B, C collinear, you can conversely say that AB could be written as K times AC, whatever relation that you would like to have. So in this case, this is AB, let's say, and we have AB is equal to half of AC, or minus 1 over 2 AC. All right, let's say AB is equal to minus 1 over 2 AC. So it's equal to 1 over 2 CA. Okay, instead of choosing AC, we can write CA. So what does it mean? It means that we have this common point, which is A in this case, A. Since we have this common point in the same relation, it means that the 3 points are collinear. So the point C actually will be at this position, So AB is the half of AC and in the opposite sense. So it's minus 1 over 2 AC. So A, B, and C are collinear. So this was the third case. Now what happens when we have again we're going to use vectors in order to demonstrate that a certain point called I is the midpoint of a segment AB. So if I is the midpoint of AB, it means that I can write down IA is equal to minus IB, or IA plus IB is equal to 0. So this is related to the midpoint. So this is our segment, let's say AB, and I is the midpoint. So IA plus IB will be equal to 0 since I is the midpoint. So if you had IA plus, excuse me, it should be with vectors, yes. So in case I had IA is equal to minus IB, or IA vector plus IB vector is equal to 0 vector, again conversely I can say that I is the midpoint of AB. Now in the general form, if we had a certain point, let's say O, this is the point O, and I'm willing to find what result will I get when I do the addition of OA plus OB. Whenever I'm calculating OA plus OB, it's the sum of two vectors having the same origin. It's true that it's you should complete the parallelogram and it will give you the fourth vertex of this parallelogram, but in this case I'm interested with the point I, with the midpoint I. So I can write it down as OA plus OB is equal to 2 OI. Now how am I supposed to demonstrate or to prove this relation? This relation, you can use it directly, of course. How am I supposed to prove this relation? Very simple. You simply have to say we have OA plus OB. That could be written as OI plus IA. So I'm integrating the point I by using a triangle rule or a Chasel's rule, plus OI plus IB. Now IA plus IB is actually 0, just like we have already said previously. So OA plus OB will be equal to 2 OI. And this is how you get this relation. All right. So whenever you have a certain point I, which is the midpoint of a segment AB, you can choose any point from the plane, which is in this case O. It could be at any position, and you will have OA plus OB is equal to 2 times OI. Now, what is the last one? It's related to the centroid of a triangle. So if we have G, let's say we have G, the centroid of a triangle, I can deduce that of course the triangle is ABC, so GA plus GB plus GC is actually equal to 0. Or in case you had GA plus GB plus GC is equal to 0, conversely you can say that G is the centroid of the triangle. So this is my triangle, in this case ABC. All right, so this is G, that's the point G. How am I supposed to demonstrate that GA plus GB plus GC is equal to 0. Very simple. I'm gonna call the midpoints. This is, let's say, I, this is J, and this is K. So I have GA plus GB, GA plus GB. From the previous example related to the midpoint, in this case, I can say that GA plus GB, GA plus GB is equal to 2GI, and GC is actually equal to minus 2GI. This is the proportion related to the proportions with the centroid. So I will have 2GI plus minus 2GI, the resultant will be 0. So this is how you prove or demonstrate that G is the centroid and the relation GA plus GB plus GC is equal to 0. Now what happens if I choose a certain, again, point from the plane at any position? Let's say this is O, a certain point O. When the point O belongs to this plane, I can say that OA plus OB plus OC will be equal to 3 times OG. In order to demonstrate this, again, it's very simple. You simply have to say that, so this is the relation that you can, these two, you can use them directly. So in order to do the demonstration, it's very simple. You integrate simply the point G. So you will have OG plus GA plus OG plus GB plus OG plus GC. So you know already from this relation that GA plus GB plus GC is equal to 0. Whatever remains is OG plus OG plus OG. So the resultant will be 3OG. Again, this relation could be used whenever you have the centroid, G as the centroid of a triangle, and O, any point. It could be a variable point from the plane. This relation, it could be used easily. That's all for this video related to the vectors and how they could be useful in order to prove some geometrical relations. Why don't you subscribe to my channel? You will be notified whenever I upload new videos. I can also share with you my Instagram and Facebook account, so you can contact me directly, or you can leave a comment below. That's all for this time, and I hope to see you again next time.